In this video, we will do an example where we convert a sentence in words to a logical statement that involves nested quantifiers. So the example says, let the domain of x and y be SU students. R of x comma y will be x is related to y. L of x comma y will be x likes y. And S of x will be x sleepwalks. Okay, so the sentence says there is a student who likes all other students but is related to no others. So when I read the sentence, I notice there's a couple of quantifiers being set up here. It says there is somewhere, it says the word all somewhere. So when I see multiple quantifiers like this, I find it helpful to first rewrite the sentence using words that makes it more clear exactly where those quantifiers are, where I can introduce some variables that go with the quantifiers. So for the there is a student, I can write there exists, or there is a student, and I'll introduce a variable that'll go with the there is quantifier. There is a student X, such that, okay, and now I need something about, these all of these other students. Well, I don't really have a word for other in terms of quantifiers. I have a way to represent all students, so maybe I'll do that, and then later I'll think about how do I put the word other in there, such that for all students y, okay, and I'll put a comma. So now how am I going to indicate this word other? Like I need somehow a way to say that when y is another student from x, so like different from x, then that's when the situation happens where the first student likes that other student and is not related to that other student. So that kind of suggests I'm going to use like an if-then format. So that will look like if y is different from x. So if y is different from x, well, that's the way I'm going to describe the word other. So if that happens, then x likes y, but is not going to be related to y. Another way to express the word but is to use the word and, actually. They mean the same thing in terms of logic. Just the word but kind of indicates that the thing that comes before it and the thing that comes after it are contrasting one another. They're a little bit different from one another. One sounds like a kind of a positive thing. One sounds like more of a negative thing because it says the word no here. But it means the same thing as the word and that both have to happen. So x likes y and x is not related. X is not related to y. Okay, so I think we're ready to express this in logic now. Okay, so in logic, so there's a student x would be there exists x. For all students y would be for all y. And now I have a big if-then statement. So I'm going to put either a big parentheses or a big bracket, just because there's so much that I'll have to write there. So I'll put maybe a bracket. And then for my if-then, the if portion is y is different from x, which would be y is not equal to x. So I'll put a parentheses around that. That's the if part. Then I have my arrow for the word then. And then after the word then, we have an and statement. So I will put that and statement into parentheses. So and, the first part of the and is x likes y, which would be L of x comma y. So that's the first part of the and statement. And the second part is x is not related to y. So because of the word not, I need a negation. Okay, and x is related to y would be r of x comma y. So I need the negation of r of x comma y. All right, and there I have it. There I have it. So I'm going to box this. So let us go ahead and box this. Okay. Okay, so a really common way to try to write this that's not quite right is, what if instead of using an implication, what if we use the and operator? So why is that not right? Like, how is this different in terms of what it means? Okay, and whoops, I realized I accidentally erased this initial bracket here. So let me put that back in. So why is this and operator different? Well, with an and operator, for this and statement to be true, both parts have to happen. This part has to happen and this part has to happen. Whereas with an if-then, that's not necessarily the case. It's just saying that if this happens, then this has to happen. So it's not always going to be the case where the if part has to happen. So let's break that down a little bit more, because I have a for all y statement here. So for a for all y statement to be true, it needs to happen for every single value of y. So when y is the first student, this has to be true. And y is the second student, this has to be true. So is that going to happen? Well, even if I just focus on this first part, is it going to be true that for all values of y, y is different from x? Well, no. So the for all y, y is not equal to x is not true, since y, one of the values for y is it could be equal to x. Y could equal x. So because of that, there is one value of y, namely x, where if it was that value, this first part is false. And if this first part right here is false, well, that automatically makes the and statement false. So because there's one value of y that makes this part false, that automatically makes the for all y statement false. And that's going to make the whole thing automatically false. Our whole statement will automatically be false because of that. But this original sentence is not necessarily automatically false. I mean, there very well could be a situation, depending on who students like and who they're related to, where it could happen or where it could be true. Okay, another common way to try to write this would be, what if the for all y was actually inside of the bracket, right next to the y is not equal to x part? So there's a similar reasoning here. We know that this for all y is not equal to x. That is false, because there's one value of y that would make this thing be false, which is what if y was equal to x? And now in an if-then statement, if the if part is false, remember that makes the whole implication automatically true. So that part is automatically true, and that's going to make this whole statement right here automatically true. So the whole thing is automatically true. Okay, but that's not necessarily the case with this sentence. You know, there very well could be situations where this is false. It's not necessarily automatically going to be true. All right.